This video will talk about the relationship of a default route, which is quad zero, and black hole route, which is null zero. So the scenario will help us understand or illustrate the fact that when you have a public address space, specifically in this case, there could be other use cases, public address space that you are attracting the traffic to because you have hosts serving or as an application server to the internet users. And then you want to also protect your network against routing loops and DOS attacks. So in this scenario, let's draw that. You have the internet where your users are sitting trying to reach your address space 100.1.1.1 through an ISP that you are peering. So the ISP's router connects to your edge router, network edge router, and this network edge router is connecting to the data center router. That's where your 100, let's just say that you have 100.1.1/024. You have this address space that you own or have leased it, and you want to attract traffic through it. So the ISP, if you're not doing BGP or doing BGP, but it's a single link, your ISP is going to do a static route saying all traffic to 100.1.1/0/24 goes to this guy, your edge router. And you are on the edge router saying all the traffic for 100.1.1/24 goes to my data center because that's where the applications and servers are using this address space. So let's say one of these servers is a dummy interface on this edge router or data center router, sorry. Dummy 0, and it's configured with 100.1.1/32. It's a host route. So he is dummy 0 on this interface, on this router is a host route. And the others are other, but let's just say that 100.1.1.2 is not used, right? So when the user is going to come, and obviously when the traffic is coming in through the static route, it needs to go out. So here you have a default route, quad zero, pointing towards the ISP to go to the internet. So now your traffic from your user is going to look like something like this. User comes in for 100.1.1.1. ISP router redirects it to your edge router redirects it to your data center, hits the server. The data center router has a quad zero as well. These two routers have quad zero going back. to the user. So now if the user or some other user hits 100.1.1.2, what's going to happen? It's going to come in, and since it's not assigned, it's going to use this quad 0 to send it back. And this guy is, the edge router is going to use the same quad 0 to send it back. He's going to say 100.111/24 go back. So now you have a loop. Actually, the loop is just going to be like here, right here, right? So now you have a routing loop that could be used for DOS attacks, denial of service attacks. So how do I prevent that? Let's just see this first in action. So here's my user or an ISP router that's trying to reach. Here's my data center router. It's got a default back to the edge router, and it's got configured with 100.1.1.1, which is the server serving this host route. My edge router has quad 0 pointing back to the ISP and 100.1.1/24 pointing to the data center. Okay. So if I ping 10.1.1, it's getting catered, but if I ping the other one, it's going in a loop. Let's do a trace route, 2 hops, and that's a loop right there. (12:02) to 10.1.1.10, 10.1.1.3, 10.1.1.3, 10.1.1.3. It's just going a loop until the time to live expires in 30 hops. How do I prevent that? So the way to prevent that is you create a black hole route on your data center or any router that has more specific routes. So data center router has 100.1.1.1 as a specific route, and it's more like a connected route. So it would have a /24, and then that /24 would be a subnet connecting to the servers, or multiple subnets. I'm just making it very simple here. But so I have more specific routes here in the data center route, so that's where I need to set the black hole route. Watch what's going to happen here. And that black hole route is going to be a summary route of your subnet, because you're not going to be assigning a /24 0 address, so you're going to be using that. As black hole. As soon as I do that, the loop is going to stop. See that? It stopped. So I still am able to reach my 100.1.1.1, but I'm not able to reach, because now I'm black holing it. I'm not punting it back and forth and back and forth. So the route comes, the traffic comes in here to from 100.1.1.2 hits the ISP. ISP says 100.11/24 lives here. He goes to your edge router. Edge router says 100.11/24 lives on the data center router. Data center router says I do not have any specific route for 100.112, but I am going to black hole this guy because I have a black hole route. So that is how you will prevent routing loop. Now, if you have these specific routes, again, remember the key message or key points here is you can't only use black hole routes where you on the router or device where you have more specific routes. That's a key thing to keep in mind. We have that here. We cannot use the black hole here because we can use it only if more specific routes, if you subnet it. So if you take that /24 and divide that into /29s and then advertise that /29s from here to your edge router, so he's going to have all /29s now. Now you can use the black hole here at the edge because he's getting more specific routes, more specific than the black hole route, more specific than the black hole. The black hole is 24, so you need something more specific like 25, 26, 27, and so on, until you can also use /32 host routes. So more specific, so you can only use black hole routes where you have learned the specifics. So you can do a /24 into /29s or 27s or whatever, and then you can advertise those /29s from here to your edge and then put a black hole here. But in this case, I just wanted to keep it simple and demonstrate to you how black hole would prevent this routing loop. It's coming here, it's getting dropped, it's not going back and forth, back and forth, back and forth, right? So typically the edge router would have specifics, but if it doesn't and it's pointing through a static route to your data center, then data center router must have a black hole for your public address space. Typically, again, the address space would be advertised here and it would learn something to itself here. I wanted to make it simple, that's why I didn't do all that extra steps just to demonstrate that. If data center was the edge, then you would have the black hole there. Okay, so that is how your black hole null routes relates to your defaults when you're dealing with public address space and you have to prevent routing loops and DOS attacks. Hope this helps.